discussing on how to connect a 3-heat switch as part of our EAS. We need in order to do that, we need a 3-heat switch, a multimeter, 2 lamps, a junction box to get the power from, some leads. Okay, coming back to 3-heat switch, it's the same as our normal heater switches, which has heat position 1, position 2 and position 3. So position 1 is a low position, position 2 is a medium position, position 3 is a high heat position, same as our heaters that we use in our homes. So when coming back to multimeter, we need to check the multimeter is working and it should be in ohms range, and we'll check the meter is working, and if we short these 2 leads, it should come off the 0 ohms, as close to 0 ohms, which is showing 0.1 ohms, which is good. So we need to check the 3-heat switch whether it is in working condition or there is no fault in it. To do that, we will just check with these 2 probes between A and B, leaving the switch position in 0, and see it comes up with the open loop, that's no connection. Between A and C, no connection. Between A and D, no connection. So we continue with from B to C, it's no connection, and B to D, no connection, C to D. So that means there's no shorting at all in between the heating elements or the switches. So this one is in good working condition. So by changing the switch to position 1, which is a low heat position, we'll check with the multimeter again. Between A and B, there's no reading. A and C, no reading. A and D, no reading. We move to B and we'll check between B and C, there's a reading. So we draw the layout as per the 3-heat switch, which is A, B, C, D, same as our 3-heat switch. So we got a reading between B and C. So that means while the switch is in position 1, that means there's the connection between B and C, and we call it as switch position 1. And we continue our checking with the multimeter, and we check between B and D, there's no connection. Between C and D, no connection. So we got all the possibilities. Now we move on to the switch position 2, and we repeat this procedure again. Check between A and B, straight away got a reading, that means there's a connection between A and B. So we just draw that one here, and we name that one as switch position 2. We continue on between A and C, no reading. Between A and D, no reading. We change that one to B and C, no reading. Between B and D, no reading. Between C and D, no reading. So we move on to position 3, which is a high heat position, and we repeat the procedure again. Between A and B, we got the reading again. So A and B, remember we already got a reading when the switch is on position 2, and we also got a reading when it is 3. So we call it as 2 and 3, and we continue between A and C, no reading. A and D, no reading. B and C, no reading. C and D, we got a reading. So we got, say, C, so we call this one as 3. So we checked all the possibilities, and these are the possibilities we got. So we got a connection between B and C when the switch is in position 1, and we got a connection between A and B when the switch is in position 2. We got a connection between A and B also when switch is in position 3, and we also got connection between C and D when switch is in position 3. So we mark them up, now we need to find where the heating elements are. So before that we need to find which one is phase and which one is neutral. So we got A, B, C, D, same as these ones, A, B, C and D. So we can see here there's a switch position, there's a connection between A and B, and there's a connection between C and B. So we call that one as phase. Now we need to figure out which one is neutral. So if we imagine A to be neutral, and we got a possibility of short when the switch is in position 2, so A cannot be neutral. If you imagine C to be a neutral, as you can see, if the switch 1 is on, it can be short. So the next one is D. You can see here there is no possibility of shorting between phase and neutral if D is a neutral when the switch is on. So we call this one as a neutral. Now we got phase, neutral. Phase is our B, D is our neutral. So we need to figure out where are our heating elements. So we can't have a heating element from phase because straight away it will be on. So it can be from A, C. So we figure out one coil between A and D, then other one between A and C. So we got our whole setup now. You can see we got B as our phase, D as a neutral, and we got a BC, a switch 1 position, AB switch 2 and also switch 3, and CD switch 3, and we got a heating element between A, D, AC. As I reminded before, there can't be any heating element between phase and neutral and from phase to any other point. So now we got all the connections. Now we need to wire it up as per the connections. So we got our junction box, we got our lamps which are working as our heating elements. Instead of heating elements, we are assuming our lamps to be our heating element. So we know phase, so from phase to phase, which is our B, so we use red color as our phase, so which is B, and neutral black one, so which is D. Now you can see here from A to D there is an heating element. As I explained earlier, we are using our lamps as our heating element. So from A between A and C there's a heating element. So A and C, there's the heating element. Say A and C. A is going through the heating element and coming back in C. So between A and C we got a lamp which is our heating element 1. Then between A and D, from A and D there should be one more. So we just hook up A and D. We got this. So this is our setup as per our readings using the multimeter. We got our 3 heated switch up setup. So now we need to check with the multimeter whether there is no shorting for our 3 heat switch. When the 3 heat switch is in position 0, we need to check between phase and neutral after the setup. So we just check between phase and neutral, and it should come up with the open loop. That means there is no short in your connections, so it's safe to connect. Now we need to check between phase and neutral with the switch position on. As per our circuit diagram, between phase, when its switch position is on 1, see, this is our phase neutral. When this switch is on from the phase, it should go to C, C to A, and A to D, coming back to neutral. So that means these two heating elements are in series. So when our switch is in position 1, we should get a reading of the heating elements when they are in series. So when the heating elements, which are nothing but resistors in series, they will add up. So we should get a reading with the added up resistance. So between phase and neutral, which switch position is 1, so you can see here we are getting 139.6, or it's close to 140. So that's 137. So we can take it as 137 when both are in series. So with switch position in 2, you can see here the switch position 2, between only this switch is on, and the supply will go to A, then it goes through A to D. So that means we only got one heat element working in medium position. So we only get a reading of one heat element. So we should get a when we measure between phase and neutral, we should get a reading of the one heating element. So you can see here we are getting a reading close to 68. So which is approximately off of 137. That means we are sure that we are getting a reading of only one heat element. Okay, when we flick this switch to position 3, as we can see here, position 3, A and B are connected and C and D are connected. So you can see here from phase it goes to A, and it is splitted between 2. That means these two heating elements are in parallel. So you can see here A goes to C and C to D. That's one heating element. Between B and A, then A and D, one heating element, and you can see they are in parallel. So as we know that if they are in parallel, the resistance will be offed. So we should get a reading off of our actual heating element resistance. So you can see here we are getting reading of 34, so which is off of 68. So straight away we know that our 3 switch is working and it's safe to plug it in. We got when the heat switch is in 0, we got no connection between phase and neutral. That's very important thing to do before we connect it to the power. So make sure that you get no connection between phase and neutral or 0L reading on your multimeter. So we can hook up to our power. See, so when I put on 1, so that's low position. You can see here the lamps are very dim. When we want 2, and you can see we got 1 lamp going, again in 3, both lamps in bright. So 0 it's off, 1 it's low heat setting, because we got two heat elements in series, and we got the bigger resistance. As we know, the bigger the resistance, the lower the voltage. We got medium position, which one of them is working, and we got high position, which both of them in parallel. So the resistance has been offed. We got the lowest resistance and we got the highest voltage output. So basically that's how we connect our 3-heat switch, and I hope you guys will do the same. Thank you very much.